Hi everyone, this is Mrs. Pagan. In today's lesson, we're going to be talking about expressions and models. This is the day 2 of this lesson, where our focus will be on like terms and word problem situations. Alright, so let's kind of talk about what is a like term. Are you ready? Well, like terms are something like this. 3x squared and 5x squared are like terms. And as you can see, they have the same variable parts. So they both have x squared as their variable parts. Before we kind of go further in, let's kind of review. Looking at 4 times x minus 2y and divided by x plus y. So it says when x equals 4 and y equals negative 2. So we have the expression 4 in quantity x minus 2y divided by x plus y. And we're going to replace the x's with the 4. So as you can see, I'm going to kind of minimize it a little bit. Get my eraser. I'm going to erase this right here, those x's, and we're going to go ahead and replace those with the 4. And then we're going to go ahead and erase the y's that we have, and we're going to replace those with negative 2, according to this. Alright, and then we're going to use our order of operations to simplify further. So looking at this, let's change our color really quick. We have parentheses must go first. Inside the parentheses, we have subtraction and multiplication, so we're going to go ahead and multiply. Minus 2 times negative 2 is negative 4. All over 4, I'm just going to do plus minus, so minus 2. Whenever there's a plus or a minus, you could just replace it with subtraction sign. Equals, well, we know 2 negatives create a positive, so that's the same thing as 4 times 4 plus 4. All over 4 minus 2, which is 2. I'm not going to keep you waiting on that one. And that equals 4 times, in parentheses, we have the 8 divided by 2. And 4 times 2 is 32. Divided by 2 is our awesome 16. Just a quick review from last time, just so that you can remember some of these problems that we did work on earlier. Alright, let's go back to this idea of like terms now that hopefully it's sank in. Like terms are things that are the same looking, so same variable parts. So let's kind of look at example number 1. It says evaluate the following. And they're giving us this expression. So what we're going to do is simplify it a little bit, and then we'll add the like terms. We have a 3 in front of the parentheses, so we're going to go ahead and distribute. We have 3x, and then we have 3 times negative 2 is negative 6. And we could do the same thing with 5, but I don't really see that as a 5. I see that as a negative 5. So negative 5 times 4 is negative 20x, and negative 5 times negative 8 is positive 40. And then we're going to combine like terms. Well, you can see that 3x and negative 20x are like terms, which gives us negative 17x. And we also can see that the numbers are like terms, so negative 6 plus 40, well, that's going to give us positive 34. So here's our final simplified expression. All right, let's look at example number 9. So in example number 9, we're looking for like terms again. Well, this one has a y, and negative 14y also has a y, but this one does not. It's different. It has x and a y. So it's not like terms. Therefore, we can only combine these two, 9y and negative 14y. Well, that gives us a negative 5y, and we're going to leave the plus 3xy by itself. And that's our final answer. Remember, those are not like terms. One has x, the other one does not. Alright, let's look at example C. So I sometimes get confused when there's no numbers in the front of these. So remember that if there is negative n, it's really negative 1n and negative 1n squared. So here are the like terms. we have the 3n squared and then negative 1n squared. And sometimes some people will write them out like this, 3n squared minus 1n squared, and then write negative 1n. That's all by itself. That's different. And then this one is also different. So it's just a number. It doesn't even have an n. So it's plus 2. Well, we can only add the like terms, and those are the first two terms. So we have 3n squared minus 1n squared is 2n squared minus 1n plus 2. As we get into higher levels, we just don't write the 1 and we just do this. So notice that we didn't write this 1. We just kind of left it out. But everyone knows that it's there. It's kind of silly, right? I know it is. All right, let's look at this one. D. We have 3x squared minus 5x plus 5x minus 3x. So here is x squared. It's just all by itself. But then we have negative 5x, positive 5x, negative 3x. A lot of you are already going, well, negative 5 and positive 5 is 0, so you can cancel that out. And you can't combine 3x squared with an x, so a negative 3x. So we can't combine them. Well, if we can't combine them, we just write them right next to each other and call it a day. So that's our final answer. All right. So that is pretty much all you have for combining like terms. But let's go into some examples of word problems. We're going to do one together, and the other one I'm going to let you do by yourself, and we'll go over it in class. All right. You buy a used car for 37,148 miles on the odometer. So I'm going to go ahead and underline some important information. Based on your regular driving habits, you plan to drive the car 15,000 miles each year. Especially when you own it, of course. Oh, stop. I'm not that funny. Stop it. Wasn't that funny? Okay. All right, so then it says write an expression for the number of miles that appears on the odometer at the end of each year. Okay, so we're basing this on year. So first I'm going to go ahead and do y, and this is going to be number of years. And it is an expression, so I'm just going to kind of say this is going to be the total, okay, is going to equal. Now, when we bought the car, we already had 37,148 miles on it. That's never going to change, whether I want to or not. It's just not. That's how much the car had coming in. And then I used the car, obviously, because that's why I bought it. And it has 15,000 miles, but it has it every year. So it doesn't just happen once, it happens repeatedly every year. So since y is my number of years, I'm going to place y, because if it's 1 year, it's 15,000. If it's 2 years, right, if it's 2, then that should mean 30,000. And if it's 3 years, it should mean 45,000. Okay? So, oops, sorry. Didn't mean to confuse you there, but just wanted to make sure you see it. So it'll be 3 times 15,000, and that should be 45,000. So it increases as you own this vehicle more and more each year. All right. So that is our expression that they wanted from us. Well, let's kind of continue reading, see what else they want. It says, evaluate the expression to find the number of miles that will appear on the odometer after you have owned the car for 4 years. So now they're telling us that y equals 4 years. So what they want us to do is use the equation, the total, which is the total number of miles. 37,148, remember, miles were already on there. Plus 15,000 miles for each year, and in this case for 4 years. So we end up getting T equals, I'm actually going to erase the years because the units will kind of confuse me sometimes, so I'm just going to erase that one. But when we multiply this, we get 37,148 miles plus 15,000 times 4 is 60,000. So when I add these two lucky numbers, we get 97,148 miles that she would have driven, or you have driven, by the end of the 4 years. Now, each problem is different, and sometimes they're easier and sometimes they're harder. What I'd like for you to do now is try example number 3 all by yourself, and we'll go over it first thing in the morning when I see you. Have a wonderful day. You did an awesome job. Give yourself a hand of applause. See you tomorrow.